What's up, YouTubers and YouTubettes? So today we're gonna go over the MOT, the microwave oven transformer, and what we're gonna make is an arc furnace and a welder. And I'm gonna make a 4 transformer gang. And so what I'm gonna do first is a lot of people will cut these here and here on the welds, but I've had them to where there's solid pieces all the way through and through. And I also find that cutting the welds and then putting them back together makes it a lot harder. One, because it doesn't go back together good, and so when you go to adhere the top and bottom back together, you'll get a lot of clamoring, which a lot of noise, and then your saturation happens a lot faster. And for me, I tried and tried and tried to pack a new coil in here, or pack it and then put it in here, and I could not do it. But to pack it in here, to wrap it around and around and around, I find it to be much better, and I was able to get a lot cleaner of a look. As example, so here's one that I've done. You can see I got a wrap pretty good. And so then this is old computer heat sink, and so I've got this glued on the top to help dissipate the heat. And so this one I've also done, and this is not a heat electrical wire, which I already have it wrapped, and so that's why I'm not going to redo it. But do not use wire that is not meant for high heat areas, because it will melt. As an example, completely melted together, and you can see, I mean, the wire literally is melted to continuity. So it's got to be a high heat wire. And so anyways, what I'm going to do is take a chisel and cut through here and cut through here on both sides, only on the secondary, which is the thin one here. Well, there's 2 secondaries. This is also a secondary. But so anyways, this one's gonna stay and not get damaged, and then everything else is gonna come out. And when I get to that point, I will be back. Alright, so I changed my mind. I'm going to show you just how easy it is to take a chisel. And so I took this to my grinder and sharpened it. And then make sure the shunt isn't poking out. It was on the other side, so it is a little right there. So just make sure you're above the shunt. And just like that, it's through. So doing it this way is really easy, and then I'm going to take a punch and pound it through this way. Alright, so probably took me, I don't know, between 3 and 5 minutes to get it cut like that on both sides. And so now I'm going to take a punch and punch it through right here. But I'm going to set it on a vise like this, so that way I can punch through without any impedance and not mess up this on hitting it on the ground either. As you can see, done a pretty good job of not even nicking it once yet. So now pretend you do nick it. This wire bends pretty easy. Typically it's aluminum with a copper coating on it. Just take like a hot glue or whatever and coat it with hot glue and push it back into its place, and that will recoat it good enough so it won't be conductive to other wires in the same wrap. Alright, so it took me probably 5 or 6 minutes to pound those out. Then you see the shunts are out too. And so now what I'm going to do is I'm going to take my wire and I'm going to start winding it. I'm going to go clockwise, but it doesn't really matter because you can end up going clockwise at the end. Anyways, but so I cut my wires into 25-foot lengths, and I'm going to try to get as much in here as I can. And so that is going to be a crucial part into how this works in the end. And so what's going to happen with our length is we're going to turn this all on, and then we're going to check the voltage that's coming out of our secondary once we get it wound up, and we're going to see what it is, because we need our secondaries across all of them to be real close to the same, if not the exact same. Because if one's high and one's low, then the high one will do the brunt, or the low one will, of the work, and you'll burn out your transformers, versus if they're even, they'll spread the load. And so that's real crucial. But I mean, you can always take a wrap out or add wrap later, odds have it, depending on how you do your wires at the end. So just don't cut your lengths until you know for sure you're ready to cut them. So one other thing I just thought of is it's always nice to file these edges right here before you start putting your wire in, because these are sharp edges. And so when putting your wire in, you'll pull it, and those edges will cut your plastic. And then down the road, when you're using this, the vibrations that it causes, this lip will vibrate up and down like that, or the wires will like that on it, and it will cut it that way too. So make sure that these are smooth enough so that it won't cut you. But then also, we're going to end up putting super glue down in here, not super glue, but hot glue down in here to help hold it all solid once we're all said and done. Alright, so I've got it hooked up to power, and so now I'm testing it to see what the volts come through. So I was at 19.5, but one of the other ones I have was at 21.5. And so now I put 2 more runs on here, and now I'm going to test it again and see where it's at. And that's what I got. It was 21.8. So I ended half wind and it was 21.3. So that kind of stuck in the middle, because the other one's 21.5. But so that's probably just the difference in transformers anyways. And so I'm going to wrap up the next one. Alright, so now one thing that a lot of people get wrong when they're wiring these is, so if you look at them, so there's 2 here and the 2 here, you'd naturally think that this one would be where the power would come in. But it's actually, this is where it comes out. So this one comes out of, or it goes into plastic, whatever there, and then comes over and then dives in here. To where this one goes in, comes around, and then comes over there. And that's the exact same with this one. This one goes around, goes down and in. This one comes around and goes around the back. So this is the power in, this is the power out. And so when you're wiring them, you have to keep that in mind, depending on if you're doing 120 or 240. Alright, so I've got these 2 wired in 240, and so I have 120 going into each of these legs here. So 120 here, and then 120 here, and then these 2 are just joined together. They're just joined together, floating, so they don't go anywhere. Okay, so then on the other side, on the secondary side, this would be the power out. So these 2 are together, the power out. So you see it's coming out there, and then this one I have coming out right there in the back, and they're just together too, floating like that one. And so then on this one here is my ground for the negative or whatever, and then this one here is the positive. So coming out, red's the positive, yellow's the negative. Okay, and so then plug this in real quick. Alright, so just to show you, I guess just to show you, certainly capable of welding. And I mean, this is 3/4 of an inch thick of steel, and it'll weld right to it, no problem. But yeah, and so that's just with these 2. And so now I'm going to figure out how to get all 4 of these wired together, hopefully. But again, that's these 2 in 240. Alright guys, well, that's all I'm going to do for this video. It's getting kind of long, so Also, I'm not 100% sure on how to get a 4 gang of these to go together yet. So, anyways, this is a perfectly good way to do 2 and get them going good. I've done a lot with these and a lot of welding. I never even had a welder until I had figured out how to do this, and it has literally been a lifesaver to have. And, I mean, cost me basically nothing. I highly recommend it. It's well worth it. Anyways, guys, till the next one. It'll be part 2 when I get these 4 ganger going.